All right, our objective for today, I can solve for the missing side of a right triangle using the Pythagorean Theorem. Let's read together. 1, 2, 3. I can solve for the missing side of the right triangle using the Pythagorean Theorem. Pythagorean Theorem. So today we're continuing on, and if you notice, we're no longer in quadratic equations, but this is something to the side of that, a little side step to it. And I'm going to go ahead and show you what the Pythagorean Theorem, where it comes from. But for the Ferrier model, I want you to fill in the center of your Ferrier model, right triangle. I just want to make sure that we're covering all the terms in regards to a right triangle. So in your Ferrier model, we're going to write what? Right. So a right triangle. Okay, so what is a right triangle? A right triangle is a triangle with one 90-degree angle. A right triangle is a triangle with one 90-degree angle. Examples. Copy these down. And as you're copying those down with your red pen, if you have one, you're going to label the 90-degree angle of each of those. So, for example, this one is right there. This one is right there. And this one is right there. And it has a purpose for that, and I'll go over that as soon as you guys copy that. Copy that, please. Okay, some of the terms that I wanted to cover for this. Yes, these are right triangles because it says a triangle with one 90-degree angle. Okay, there it is. But here are some of the terms that I want to cover. Does everybody see the two sides that join to make the 90-degree angle? Yes. So for this one, it's this side and this side. They join and they make a 90-degree angle. For this one, it's this side and this side. They join to make that 90-degree angle. For this one, it's this side and this side to join, and they make the 90-degree angle. Those two sides on each of those triangles are called legs. Legs. Label that, please. So like that from now on, when we're talking about right triangles and I say legs, you understand that it's the two sides that make the 90-degree angle. So far, so good? But notice that if we label these two and these two and these two legs, then there's a third side that we haven't mentioned, which is this one right here. This is the longest side. If you notice, it's the longest side, and it's the longest side. That longest side, it's usually found across from the 90-degree. Notice it's right across from the 90-degree, right across. That one has a specific name. The specific name is the hypotenuse. Hypotenuse. The hypotenuse is the longest side on a right triangle. If the hypotenuse is the longest side, what are the other two sides named? Tell your neighbor again. Very good. Legs. Oh my goodness. You see what I did there? Yeah. All right. So once again, if the longest side is the hypotenuse, the other two sides are called legs. Oh, very good. All right. We got that, right? Okay. Let me show you some non-examples. Copy these, please. As you're copying those down, you're thinking these are not right triangles because, don't say it out loud, keep it to yourself. Okay? All right? Talk it over to your neighbor, tell them why those are not right triangles, please. What's that? What? Okay, here we go. So when I ask you why these are not right triangles, I want you to justify it. Tell me why, but using the definition. Okay? So using the definition, you're going to tell me why these are not. So, starting with these two right here. Why are those not right triangles? Charlie?
The short one is not a triangle because...
No, I'm talking about these two right here.
Yeah, it's short.
It's not a right triangle because...
Because it's an equilateral.
An equilateral, okay.
So
but I said...
Have any right.
You don't have any right angles, okay. How about this one right here? Matthew?
It's a triangle.
A triangle without the 90 degrees. Okay. How about this one right here? Caleb?
It has 4 sides and has 4 right angles.
4 right angles, and according to the definition, it's one angle, and it's not a triangle, it's 4 sides. How about this one right here? Beto?
It doesn't have any angles.
It actually does have angles. Now, I'm taking you back to the day that I introduced, that I introduced using that movie. We actually saw basic vocabulary.
Oh my God, I love it.
What is the definition of this? Talk it over with your neighbors here if you remember. How many angles does this one have?
360. Can we watch that movie again?
Then,
Oh, we should. For like during the test, we could.
yeah, during the test, yeah. Okay, Maya. How many? Yeah. According to the definition that they gave us, it said an infinite amount of angles. Is that correct?
What?
Who said that?
I said it.
Okay. And if you think about it, let's think about it. Imagine that it has. We start off with a hexagon, then an octagon, then a decagon, and we keep going. And all of a sudden, it starts starts looking like a circle, right? Because it continues having angles, very little angles, until now we can't even tell how many angles it has. Can anybody picture that?
Yeah.
All right. However, to simplify it, how many degrees in this figure? Tell your neighbor, please. That is correct. So, hashtag. Caleb.
Right angle.
Right angle.
Wait, 1 right angle.
1. Oh, 1 right angle. My bad.
Oh, we can't do that.
I did.
Just did that.
Another one.
Triangle.
Triangle. Another one. Legs. Hypotenuse. Yes? Is that it?
Only 3 hashtags.
Only what?
Only 3 hashtags.
Only 3? Okay. Hashtag only 3 hashtags. Mr. Q. Thank you, Jocelyn.
Can you write that?
Oh, Ben, no. All right, copy the steps. There is none, because you're coming up with your steps, right? Very good, because just a reminder, buying your check is coming up pretty soon, and I am going to be checking to make sure that you've been writing steps for the lessons that I've been giving you steps as we work them out, but you have to be writing them down, right? Yes, Mr. Q, I love this. Good. It's coming up. I'll let you know.
But like, do we,
I don't know.
like, do we, like, last day of
Freshman year,
school?
you should be evil or you're not talking.
Bam! Wow, be nice. All right,
You know what, I'm gonna just borrow my notes.
here we go. On your paper, copy this triangle down, please. Underneath the square model, you left space for your steps, right?
Yes.
On the Q column, you can actually fit this if you write small or draw small. But if you don't, do it in the back, please, because you're going to need some space all over the triangle for notes and stuff. So put this like maybe towards the center, like if there was a Frere model, put that towards the center. In the back, yeah. All right, so today, I mean, some of you already heard of the Pythagorean Theorem, right? And some of you actually already know the Pythagorean Theorem, but today I'm going to develop the Pythagorean Theorem the way it was developed a long time ago. Now, there was a mathematician, his name was Pythagoras of Samos. Samos is an island that is near Greek, the Greek peninsula, or whatever you want to call it, okay? Now, this person was a mathematician, and according to tales, it says that back then, they started persecuting mathematicians. And they started persecuting mathematicians because, for example, let's say somebody needed to know, let's say a kingdom found out that there was another kingdom coming over to attack their towers, or, you know, their territory. But they were far away. So they would send a scout and a horse to ride for about a week or so till they got close to, they saw the other people that as they were coming, and they would find out, you know, the distance. But the mathematicians actually gave them specific orders as to tell them, you know what, I'm going to give you this instrument. It could be whatever instrument. It could have been like a little stick, and said, put it at this distance from you, and I want you to see from far away, and I want you to count in seconds. How long does it take their army to march from here to here? And bring back that information. With that information, the mathematicians will be able to figure out how many days it would take the army to reach their kingdom. So then the king will call the mathematician, okay, bring Q master. So here comes Q. And then they're like, okay, Q master, when is the army arriving? The army's arriving 2 days from now at 6:15 p.m. And all of a sudden, guess what? 2 days from now, they're already prepared. 6:15 p.m. comes around, and all of a sudden, here comes over the hill, and they see the army. Everybody's like, wizard! You know what I'm saying? Yeah, exactly. So they thought that mathematicians were wizards. So some kings started figuring that and said, you know what? If this person can predict the future, then they can probably steal our kingdom. So let's you know what? Let's just get rid of them.
But wouldn't they need them since they tell you the army?
Exactly. Right. So according to some of the historians, they started persecuting and trying to find Pythagoras because he was one of the mathematicians in those days. So what he did, he found some patterns in regards to triangles and other math, but in order for him to give that information to others, he did three things. These were the three rules that he would go. He would start going from town to town, and he would find mathematicians that, number one, did the math in their head, number two, did not need to write down any numbers or information, and once they did those two things and he was able to convey and talk Mathanese with them, then the third thing, he would give them a medallion so that he knew the contact person in that city. The medallion was a circular medallion, and guess where was the center of it? A triangle, that is correct. They were known as the Pythagoreans. The Pythagoreans. So anyways, so the Pythagorean Theorem comes from that time. So let me show you what he found. Look up, please. He found that in a right triangle, pay attention, please, writing utensils down. You'll copy at the end. He said, he found a pattern where if he labeled this a certain number and this a certain number. So watch. At this point, I'm going to show you what he found. Let's say he labeled this one 3 and this one 4. He saw that by doing this and this, pay attention, don't say it out loud, keep that in your noodle. So he started here and he got this. He started here, he got this. Are we there?
Yeah.
He said, I wonder if these don't say it out loud, keep it to yourself. Now, some of you still don't see it. For those of you that don't see it, here it goes. Let me show you, let me do some math. technology right here with this, so watch. So I'm taking this one, yes?
Yeah.
Does everybody see it here?
Yes. What?
Talk it over to your neighbor, see what you see.
They both made it have one thing. Number 2 in my
All right, let's see. Who can explain it to us? Who saw it already? Let's see. Caleb.
Okay.
What did he start with?
Start with
3. And what did he do to the 3?
split it.
And then?
He got the 4 and spread it.
And then?
He made a square out of it.
So you made a square over here, but since we don't know what it was, let's say we label it X. So then what do we do to these two?
You add them.
Okay, so let's see. 3 squared is 9. 4 squared is, this is 25. How do we get rid of this squared? Square root, so therefore 5 equals X. 1, 2, 3, 4, 5. And that's the Pythagorean Theorem. Copy that, please. Bam! Pretty cool, huh? Copy that, please. Okay. So just to elaborate on this, look up, please. What is this pattern called? It's called the Pythagorean Theorem. Let's generalize it, just like they did back then. So he said, wait a minute. So if I can do that with that number and that number, and if I continue changing numbers, and he saw that it did work. So now, to generalize it, I'm going to use variables. He said, these 2 legs I'm going to label A and B. And this third leg I'm going to label what? C. So with those terms, tell your neighbor the Pythagorean Theorem, please. That is correct. A squared plus B squared equals C squared.
So why can't it just be A plus B equals C?
Because if you just add 3 plus 4, that does not give us 5. That gives you 7, right?
Because there's 2 square roots on one side and 1 square root on the other side.
Right.
Yeah.
Good. Everybody got it?
No.
Yeah. All right, next. Now let's use some algebra. So I want you to get this blank sheet of paper, fold it in half like this, lengthwise, or vegan wrap, or carne asada burrito, whatever you want to label it, like this. And in order for you to see from back there, I'm going to use a marker, but you're using a pencil. So watch. You fold it like this. Look up, look up, look up. You fold it like this. Put it flat on your desk, and I'm going to place 4 points that are going to be the vertices of a square. So 1 here, 1 here, 1 here, and 1 here. 4 points that are the vertices of a square. Does everybody see that? Once you put your 4 points, I want you to go over it a lot with your pencil, a lot, like go heavy on it, so that once you open this, you can see the points translucent to this side. Does everybody understand what I'm saying?
Yeah.
So when you go over like this, you open it like this, you're going to see the 4 points here also. So you're going to have 2 identical squares, something like this, side by side. Once you have your 4 points, connect the 4 points like so. Now let me do it on the computer so they can see. So you started off like this. I said fold it in half, that's your half. You're going to place 4 points that are going to be the vertices of a square. There it is. Everybody see it?
Yeah.
And then, when you open it, my goodness. When you put it side by side, you should have 2 identical squares like this. Yes? All right, connect the dots so you can make your square. So, all right, something like that. All right, here we go. I'm going to zoom in. Now, I know your squares are not going to be as perfect as mine, but...
Wow.
No, I'm saying because I'm using the tools right here. I don't mean to be mean. All right, here we go. So, halfway here, this segment is about right here. I'm going to go a little bit further to the right. I'm going to place a point. I'm going to label this A and B. Since this is a square, that means this side measures the same as this, so I'm going to place a point right here. I'm going to label this A and B. So if that's true, then I can cut this like this and like this, and now we have an area model. Does everyone remember this?
Yes.
So what is A times A? A squared. What is A times B? AB. And this is really crooked right here. Let me straighten this out. All right. What is B times A? AB. And what is B times B? B squared. All right. Let's do something similar to this. The point goes right here, so this is AB. Right here, it's AB. But for this one, I'm not going to use the same method. I'm going to do this. Look up. This one is up here somewhere, so this is AB. And this one is somewhere over here, so this is A and B. So I'm still going to cut this one into areas. I'm going to do this, this, and this. So, look up, please. Look at this one. This is a rectangle, yes?
Yes.
And it was labeled AB. Does everybody see that this one is almost like this? Does everybody see that? You don't see this here?
Huh?
Okay, here it goes again. Do you guys see this rectangle right here?
Yes.
Do you see it here?
Yes.
Yes, but in this case, since we didn't draw that, we're missing that piece. So if we can't have that piece, and this one is AB, what can I label this piece? What can I label this?
Half of AB.
Half AB. Very good. Because it's half, right? That means this one is also half AB. This one is half AB. And this one is half AB. And with some of the vocabulary that we used earlier, we know that these are triangles, aren't they? And they're right triangles. Okay? So if this is a right triangle and they label this one A and B, what can we label this third side? C. Okay? And if this one is C, what is the area in here? C squared. Oh my goodness, you guys all right?
No.
Alright.
How did you even get C, Mr. Q?
Okay, if this is a triangle, this is A and B, what is this side right here? C. A, B, C.
Squared, B squared, and C squared.
That's the Pythagorean Theorem. Right now, I'm just labeling the sides.
Okay.
Alright, here we go. So let's do some algebra. Let's lay this out. What's inside here of this area for this square? We have A squared plus how many ABs? 2AB plus B squared. And this square is almost identical or equal to this one, right? Because we got it from the same four vertices. Is that correct?
Yeah.
So what are the areas together? Let's see. Half AB plus half AB, that is 1AB, plus another AB, that is 2AB, plus, what else? C squared. That is correct. Let's simplify this. All right. So what's the same here and here so that we can get rid of? Subtract 2AB, subtract 2AB. This cancels this, and what do we have left? And that's another way of approaching the Pythagorean Theorem using areas, or the area model. Does everybody see it?
Yeah.
Yeah, some of you are in shock. You're like, I don't know what's happening, Mr. Q.
I really don't.
Finally broke
So you're going to be doing some more of this next year in geometry. So I'm just giving you like a little taste of it. Turn your paper over, please. Copy this. Example Q. Example Q.
Wait, on this paper?
Yeah.
But I wrote my...
Turn your paper over. Copy this.
My doctor right there.
Doesn't matter. Behind one of the papers. Example Q. Okay, let's do this one together. This one has side measures 8 centimeters, and the other leg is 15 centimeters, and the hypotenuse is labeled C. So, we start off with the Pythagorean Theorem. A squared plus B squared equals C squared. So what is A? Very good. 8 squared. What is B? 15 squared equals C squared. 8 squared is 64. 15 squared is 225. Very good. Equals C squared. 225 plus 64, that's 289 equals C squared. Square root of this, square root of this, plus minus equals C. What number times itself gives us 289? 17. So, what is the missing length right here, everyone?
17. 30. Plus minus.
Plus minus 17 centimeters. Let me ask you this. Is it plus minus? No. Why not? Because it's a distance and we don't use what? Negatives for distances. So here, even if the answer is C sub 1, 17, and C sub 2 is negative 17, in this case we don't use the negative because we're talking about distances. You understand? Okay, copy this one. Example super Q. Do that one by yourself. You got 30 seconds. The legs are 30 feet and 40 feet. Find me the hypotenuse, please. Copy that and go. What'd you get for this one? Felipe. C equals what? 50. Hands if you got 50. That is incorrect. We got 50 feet.
Oh, yeah.
That is correct. Yeah. Yeah. A squared plus B squared equals C squared. 30 squared plus 40 squared equals C squared. 900 plus 1600 equals C squared. 2500 equals C squared. Square root 50 equals C. And I'm not done. One more. In your graphing paper, copy this one. Yeah, the graphing paper. So, E, what are the coordinates for E?
4.
4.
1, 4.
1, 4.
I knew it.
What are the coordinates for F?
4, 4.
4, 4. And the coordinates for G?
1,
1, 9. Okay. So they're asking us to find the distance between F and G. So we use the Pythagorean Theorem because this is a right triangle, right? A squared plus B squared equals C squared. What is A? 5, that is correct. 5 squared. Plus, what is B? 3 squared. Let's see, how did we get that? Let's see, from here to here. 1, 2, 3, 4, 5. All right. From here to here. 1, 2, 3. All right. Equals C squared. So what is 5 squared? 25. What is 3 squared? 9 equals C squared. This is 34 equals C squared. To cancel the square, we do the square root. Uh-oh. Square root of 34, we need to do what? Estimate. Do we know how to find that? Yes, you can do that on your own. So for tonight's home play, there's a play sheet. Grab one on your way out over here. There is tutoring if you need to stay. If you don't, have a good one, guys. Enjoy your home play. See you guys tomorrow. Bye.